So very good evening to one and all present here, and it's my pleasure and privilege to moderate the today's discussion, which is quite interesting and timely. We can say the tech-driven advancement reshaping India's transmission and distribution. We all know that the Indian power sector is undergoing a significant transformation with the rapid growth in the renewable, the battery energy storage systems, the increasing in line with electrifications, rising customers' expectations, moving towards smart grid implementations. So the technology is no longer just an enabler, and it becomes a backbone of our power infrastructure. So as and when we talk about the renewable penetrations, battery energy storage system, and the new upcoming technologies that will be there, like green hydrogen, offshore wind power potentials and all. So the investment and the capital expenditures as far as the roadmap for Indian power sector is concerned, the key challenges that are totally associated with the Indian power sector in line with developing a future ready power system. So we have predicted that by 2030, we will have a 500 gigawatt of renewable penetrations. Whether our grid, particularly transmission and distribution grids, are sufficient enough, or which kind of additional infrastructures we are in need to digitalize that, to make that grid compatible to meet the demand. So we are fortunate here that we have three distinguished speakers who will bring the diverse and valuable perspectives of these critical areas. Would like to start this panel discussion to questioning the very first question to the Kaushal sir. He is the head of business development L&T power transmission and distribution. Sir, as per India, like India has announced that the ambitious renewable energy 500 gigawatt by 2030 and a net zero target by 2070. As per your perspective, which transmission infrastructure investment should be prioritized over the next 5 years to support this energy transition?
Thank you, Dr. Manan. I'm very impressed with your profile. You are doing PhD in transmission line optimization.
Yes, sir.
I think this is very essential for our transmission sector. We
Yes,
are
sir.
hearing a lot of news and challenges that the transmission sector we are facing.
Yes, sir.
There are always, we are hearing that renewable capacities are available and the transmission system in India is not able to evacuate the whole power. So
Yes, sir.
yes, a very pertinent question that you asked, sir. And like my submission and understanding of the domain as of now, that what I see is the priority transmission investment, it must focus on interstate green energy corridor because we are adding a lot of green energy. So high capacity, long distance links, and which should also include grid scale storage integration. So we are coming up with pumped hydro storage. We are coming up with renewable energy zones. So the transmission infrastructure must focus for evacuation of power from renewable energy zones and focus funding on these high potential solar and wind regions like Khavda in Gujarat, Fatehgarh and Bhadla in Rajasthan, and Ladakh, which is there under under you can say planning stage and feasibility state if it comes. So one is the renewable energy zones, the transmission infrastructure we need to evacuate these power from these zones. And second is the intra-state upgrades. We need to invest in expanding our state level in networks supported by MNRE and Green Energy Corridor Framework to clear the local bottlenecks. So Green Energy Corridor Phase 3 scheme is also coming up shortly. So going a little bit granular, I think we must invest. Point number one is high voltage HVDC kind of dedicated corridors to move bulk power over long distance from remote generation hubs to dense urban load centers. And the second is an inter-regional capacity. Scale up the inter-regional transfer capacity to balance regional power surplus and deficit seamlessly. So as we were talking about 2030 adding 500 gigawatt of renewable energies, so we would be needing something more than 1,23,577 circuit kilometers of fresh high voltage transmission lines. And transformation capacity, we would be not doubling, not tripling, not quadrupling, rather going 5 times. We'll have to have a 7,22,540 MVA. In terms of giga MVA, 7,225
Okay.
giga MVA with present of 1,400 MVA.
Perfect.
So we would be needing at least 32 gigawatt of HVDC network to build out. So we look forward to investment in this domain.
Sir, one
That's my
follow-up question in line with the same. Recently in Rajasthan, there was a power curtailment of around 2 gigawatt solar. So will this be in line with the same, like as we are in need of upgradation of transmission infrastructure, and just because of lack of infrastructure facility, we might need to curtail certain solar generated power which was available, but just because of some infrastructure based issue we need to curtail some sort of power. So will this green energy corridor, or we can say intrastate transmission corridor, helps reducing certain curtailments? What's your view on that, sir?
Uh, with the recent event that you just cited,
Yes.
it's very difficult as of now to give the exact solution which will be applicable. But primarily, we'll have to see the grid stability. How
Hmm.
much is the grid ready to absorb the renewable intermittent power that is being feeded?
Okay.
So we have to see that. And one of the solution is to come up with the grid storage at the transmission level also.
Yes.
So I think a lot of renewable developers are also planning to
Yes.
have some sort of a, battery energy or other source of storage of energy, so that
Yes.
they can store the power at the peak period and they can feed it into the grid. So it depends upon the dynamic grid stability, and the
Hmm.
HVDC kind of transmission systems are basically asynchronous grid connections, so they will offer definitely grid stability.
Okay, okay. Thank you, sir. Now, keeping in line with renewable penetrations in a continuation, I would like to ask questions to Dr. Rajesh Arora ji. Sir, as renewable penetrations are continuing to increase by 2030, 500 gigawatt, and it will get rises. So, what do you see as the biggest technical challenges that India is facing in line with transmission and distribution network? Will it be in line with grid flexibility, stability, energy storage, cybersecurity issues? And maybe if you can elaborate more in line with why certain issues, certain challenges that India right now is facing in line with the transmission and distribution network.
Thank you very much for asking this very pertinent question.
Yes, sir.
I will try to reply in systematically, in
Yeah.
point wise. For
Yeah.
example, when you design any system,
Yeah.
first of all, you want your system should have good quality.
Yeah.
You must design based on the reliability of the system. And then in the present era, we need everything smart.
Mm.
When I say smart, at the same time, we have to ensure safety. Safety may be of electrical safety, cyber security. That is again the safety against digital safety, basically. Then comes flexibility, economical, efficient, cost effective.
Yeah.
And that is called stability of my system.
Yeah.
Technical challenge, the most important challenge when you talk about integration of RES with my grid is the challenge of intermittent power, intermittency. You get that solar power for 4 hours, 6 hours in a day.
Yeah.
If you look at the data of total installed capacity, if you look at the target of 777 gigawatt, that will be contributing around 62% of my total installed capacity at that point of time in 2030. Will we be able to extract that capacity for 24 into 7? That is the target. You can't achieve that thing without use of two important factors I explained in my presentation.
Mm.
Use of BESS and pump
Yeah.
storage system. If you implement that technologies of BESS as well as pump storage system. And very rightly said by Kaushal sir, we must have good green corridor to transmit the power from one side of part to second side of it. That is called inter-regional transmission capability. We have to work in that direction. We have to develop HVDC to transmit bulk power from one side to another side. If you go deeper in the technical aspects, my power used to be one side. Now it is bidirectional.
Yeah.
We have to ensure islanding schemes, provisions. I have to look at the inertia that plays vital role. I have to look at the short circuit level, technical point, if you talk about the technical aspects, and coordination of protection system I have. With change in the inertia, with change in the fault level, will I be able to make my system safe, protective with the available infrastructures I have? I have to work in the directions of giving proper protection coordination, develop new corridor, make provisions of transmission of bulk power. There should be provision of inter-regional transfer capability. There should be provision of flexibility. And after flexibility, the stability. And above all, the cybersecurity can't be ignored.
Yes, it's true, sir. Very true. Sir, just a follow-up question. As you mentioned, the safety concerns are low. Recently, there was an incident in line with battery energy storage system.
Yes.
So, sir, what's your point? What's your view on that, sir? Like how India, because there will be a need of battery energy storage system, and without that, we can't expect our grid. And simultaneously, we are experiencing certain accidents. So, like, what's your comment on it, sir?
Sir, I am already on a mission to make India free of electrical and fire accidents, and on a mission to make India free of asset failure happening almost every day. The point is, the safety aspect at any cost can't be ignored. We have to make our specification. What happens when you procure any material, be it BESS or any electronics gadgets? It comes with some specification, technical specification. You have to make adequate changes in the specification that ensures safety. When I say safety of BESS, it has three important components. Power conversion unit, my battery, my cells. To take care of my battery, BMS is there. There are cooling systems are there. But to run that cooling system, you need power. You need proper earthing bonding, proper protection system. You need proper firefighting system. You need proper arcing detection and fighting system. If you work apart from the development and integration, that safety aspect should not be ignored, and we have to work in that direction to ensure that there is no asset failure because of negligence, fire, short circuit in my system.
Yes, definitely, sir. Thank you. Thank you very much, sir, for your view. Now, my next question is to Mr. Prashant Krishna. Sir, in line with RDSS program, we know that the RDSS program is accelerating the smart meter deployment across the India, and I guess the state Gujarat, UP, Maharashtra are quite pioneer in line with adapting the smart metering infrastructure. Now, beyond reducing AT&C losses, what additional value can the grid or utilities unlock from the smart meter data for the consumers and the grid operations? Sir, what's your view on it?
It's a very interesting question. You know, when you talk about smart metering, most of the people link it directly with the loss reduction or the billing efficiency that is very beneficial for discoms. Now, of course, those are important outcomes, but I think That's the only starting point. Today, if you talk about the data size, the millions of smart meters are continuously sending data from smart meter to DCU to HES to MDMS and so on, and creating a huge digital footprint for discoms.
Yes.
Their real value is not I think meter. The real values lies under this RDSS scheme or smart metering scheme is the data. Usually earlier at the time of RDSS or IPDS, what was happening was like users used to go to the field and collect the data, but that is not happening now. That they are getting almost real time, almost every 15 minutes the data. Through that they can get real insights. Okay. And using analytics on the top of MDMS data, utilities can forecast demand forecasting, identify the theft, detect the overloaded transformers. They can improve the outage management outage of happening in the distribution level, at the consumer level or the field level. And if I put it simply, the smart metering are not the just the meter replacement program. It's a data transformation program for discoms, and the utilities that learn how to convert this data into actionable insights will be the real winners in the coming years.
Okay, great, sir. Now I again would like to come to Mr. Kaushal. Sir, you mentioned in your previous discussion HVDC corridor. So now with increasing in investment in HVDC corridor, the digital substations, and again the battery energy storage and the renewable energy integrations, how can utilities ensure that a capital expenditures also delivers a long-term grid resilience in line with an operational efficiencies rather than just the capacity expansion? So keeping that two word, the capital expenditures for the long-term grid reliance and the operational efficiency. Sir, what's your view on it, sir?
Okay. Thank you. Well, I'm not a totally HVDC expert, but yes, I'm fortunate enough to have some hands-on on HVDC project that I delivered to Power Grid while working in Siemens. And there is so what I look at it, I have been dealing with customers also, so I understand what are the expectations and challenges that a customer face and what is exactly they need. So your question is very pertinent. Like, utilities can maximize what I feel is long-term grid resilience and operational efficiency by going into HVDC. And the most important is selecting the technology, HVDC technology, which is resilient and which has adaptability, features, and flexibility for expansions and upgrades. So typically in HVDC technology, there is an option we can look at, that is a multi-terminal HVDC. So multi-terminal HVDC, it will offer you transition from, instead of one point to one point lines, to multi-terminal systems, which will allow flexible rerouting during localized grid failures. So this is one. The other is there are two types of HVDC technology. One is a line commutated converters, which is a predecessor, or you can say earlier technology. The new technology, this is not exactly very new. It is already there last more than 10 years, but it is less implemented and it's being developed for, you can say, bulk transfer also now. So that's a voltage source converter.
Yes.
So we can look at it, customers can look at it, whether they would like to go for voltage source converter or line commutated converters because, for HVDC connection lines.
Okay.
VSC, that is voltage source converters, it offers them a black start capability, and it also offers independent reactive power control. So this voltage source converter HVDC system provide reactive power compensation by acting as a fully programmable virtual AC voltage source. So VSC systems uses advanced self-commutating transistors such as insulated gate bipolar transistors, that is IGBTs. And this allows the systems to operate exactly like a STATCOM. That is a static synchronous compensator. So which can generate and absorb reactive power dynamically on demand. Point number 3 that I look at is that government of India is already pushing for a lot of make in India. So the amount of localization in HVDC product solutions will benefit in terms of our operational maintenance and managing the assets. The HVDC simulators and system study capabilities, if we develop domestically, this will really support us.
Okay,
Yeah.
great, sir. Thank you. My next question is to Dr. Rajesh, being as an R&D cell. Now, as per R&D perspective, what do you think, in line with the Indian power sector, which emerging technologies or the innovations you believe which definitely convert the transformations of Indian power sectors over next decade? And till date, what gap that we need to nullify to address certain challenges that you are facing right now? So being as a researcher, like I did my PhD in hybrid transmission line optimization studies. So I work on a single tower. There will be a AC and DC line, and will have a power transfer capability. The issues facing in line with right of way, that was kind of addressed in my PhD thesis. Now, sir, what do you think, as per the R&D perspective, which technology that India should adapt, which will transform the Indian power sectors over decades? What's your comment on it?
Okay. The very first thing I would like to say related to the development, we have to save the assets we have, the infrastructure we have. We have to optimal use all the infrastructure we have before going for the new investment. This is my personal view. When I say assets management, I have to do the proper condition monitoring with the use of the latest technologies, be it my transformer, my reactor, my circuit breaker, my CT, PT, my substation equipments. We have to use all the latest technologies to monitor the data continuously, and we have to do proper maintenance based on the data we received. We have to use all the latest technologies, like for example, if you have to do check your transformer, latest technologies are there, latest tests are there to check the partial discharge, moisture inside the transformer, then 10 delta. All these must be monitored continuously, because in the era of development, we can't afford any kind of outages, breakdown. That is not allowed at all. To avoid that thing, you have to do the proper condition meeting, and you have to take help of the latest technology already available. When you talk about a transmission line, if you go there, we don't have space, right of way issue is there. It is known to everyone. And the problem with cable is that you can't transmit power for a long distance. You have to use your circuits already you have. As you said, we have to use the same tower for using the multi circuits, or you have to change your conductor from STLS, so that you can enhance the capacity of power carrying capacity. You can enhance. You have to avoid hotspot in the system. You have to make it more efficient so that more power can be flown through your circuit. And most important thing, you have to look at the dynamic real loading of your transmission system to take a decision about taking more load on the existing transmission system. That will avoid the congestion we are facing, that we faced in the recent time, when we were not able to transmit the power generated by solar in Rajasthan.
Yes. True.
We have to use the technologies, and with the use of AI, ML, we can get more data.
Yes.
And based on the data we collect, we can take a decision. That will definitely help to use my system optimally. without
Okay.
investing more, and that will make my system reliable and it increase the stability of my system.
Yes. Okay, great, sir. Thank you. My next question is to Mr. Prasant. As India is moving towards a digitally connected distribution ecosystem through RDSA, smart meterings, and all, now how important will the data analysis, AI, just recently Sir has mentioned AI, ML, new technologies, and particularly the consumers' engagement will be ensuring the long-term success of smart metering initiative? So, what's your view on it? It is ultimately moving towards the ordinary grid to smart grid, where in developed countries, the smart grid ecosystem is already been developed well effectively. How we can connect the same? And I guess there is one participant who has also given the same question in line with AI and ML applications in the power sector area. So, I guess that might be justified with your comments.
I think analytics, AI, and consumer engagement will be absolutely critical for the success of a smart metering. And today, the deployment is only the first step, I guess. The real
Yes.
question is how utilities use this data after the deployment,
Yes.
after maybe the sunset of 2028, after the sunset of RDSS. And AI analytics and AI can help utilities in forecast their demand, identifying their theft, predicting their equipment failures, improve their outage management, and move to reactive operation to predictive operation. Now they can predict what is happening at the consumer cohort, what is happening at their transformer level, at their feeder level. They can accordingly plan and deploy the manpower to attend as a predictive operation. At the
Right.
same time, consumer engagement is equally important. I think like consumers should also see the benefits such as the consumption visibility they have as of now, the recharge alerts they are getting, the better services, and greater control overall in terms of electricity consumption and expenses also. So if
Mm.
I put it simply, AI will be converting, helping data into the intelligence, and consumers engagement converts will be converting the technology investment into, I think, real time outcomes for both consumers and discoms. Yeah.
Definitely. So, sir, recently I had a talk at PDPU, Pandit Dindayal Energy University, and it was in line with smart grid implementation. So, the question by one of the student, he was a UG student, that as such in India, like though we have implemented a smart meter, but the accessibility of smart meter, the data that you mentioned, let's say sitting in an office right now, I am unable to access my home electricity usage. So, what's your view on it? Like, will this technology be coming up in Indian power sector under the head of smart grid ecosystem, that individual consumers will get the access visibility of how much power they are using right now? And if we can connect the same with the money factor, because money is something that definitely ignite individuals mindset, right? So once
Hmm.
individual will get an idea ki, okay, this much money I'm spending right now utilizing electricity at my home, so how certain technological advancement will helps to enable this ecosystem?
I think on the top of RDSS, within the RDSS scheme, all the AMI SP service providers are providing the consumer applications for the visibility of you know for visibility to consumers. For they can see the level of consumption they have, their past pattern of consumption, how much they are consumer, how much they are consuming, how much the bill payment is due, how much they can plan all accordingly. That is already there in the RDSs, I think.
Okay, okay, then. So one last closing remarks question
But
to
if I
yeah,
talk
yeah, yes.
about overall from the discom perspective,
Hmm.
so I think smart metering operation center is something which should be on the top of all the RDSS schemes which is happening under the discom or under the state. So how it is usually happens in within a state, there are multiple AMISP, and all of them are having different of platforms for managing their smart metering information, how much the meter is installed and how much is spending, all the visibility of their project. But on the top of that, I think discoms should be having one set of unified set of platform, which is coming smart metering operation center, so they can have a state level of overview.